Okay, so welcome to all of you. Today we'll see the Leibnitz theorem. This is Leibniz theorem. So this is helpful to find nth derivative of the product. So to find nth derivative of the product, this theorem is very useful. Okay. So now we'll state the theorem. If u and v be the two functions possessing the derivatives of nth order, that means you can differentiate u and n times, then this is the product of u. This is the nth derivative of uv. So that means this is the product rule for nth derivative is nothing but a Leibniz theorem. Okay. So that is what NC0. These are the binomial coefficients. Now see here u and v is there. Okay. So this is what u v not actually. That means you are not taking any derivative of v. Okay. So this sum is what n. Sum will be n. N minus 1, 1. Okay. So the sum is n. Okay. Okay, so this is what NC0. Go on increasing this bottom, right, and give that bottom to the v now. Okay, and take the difference n minus top minus bottom will be the suffix of the u now. So that means what? This is the nth derivative of u. This is n minus 1th derivative of u. This is n minus 2th derivative of u, and so on. Okay, so this is the rth term, and this is r plus 1 term. This is r plus 1 term. The last term is what? U. So that means what? You are not taking derivative of u. Your vn will be as it is. So you are familiar with this binomial coefficient, that is NCR is n factorial upon r factorial into n minus r factorial. Okay. Okay. So we'll prove this one. Now your n is what here? We are differentiating n time. That means n is natural number. Okay. So that means what we will apply the mathematical induction of n. Okay. Okay. So proof. I'll erase this. Proof. Okay. U and v are two functions possessing derivative of nth order. Okay. Okay. So we will apply mathematical induction on n. We'll apply mathematical induction on n. Okay. So your step is what? Step 1. Let Pn denote the statement. Okay. So this is your step 1. Okay. So let Pn denote the statement. Okay. So this is your step 1. Now what? We have to verify the result for n is equal to 1. Okay. Step 2. For n is equal to 1. LHS. What? uv1 is what? u1v plus u v1 Okay. Product rule. Just we are applying the product rule. Usual product rule. Derivative of u is u1. V will be as it is. Then derivative of u will be as it is. This is the product rule as usual. LHS is equal to. Okay. Now we'll do the RHS now. RHS is equal to what? 1C0 u1v plus 1C1. This is 1C1. Okay. You have to stop. When if your top and bottom are same, then you have to stop then. This is 1C1 uv1. Okay. So we know that NC. We know that C. NC0 NCN is always 1. Okay. So NC0 and this is 1. So that means what? This is u1v plus uv1. Okay. So therefore LHS is equal to RHS. Therefore LHS are equal. So therefore P1 is true. Okay. Now step 3. Okay. So step 3. We'll have use the Roman now. Step 3. Okay. Assume that Pk is true for some k belongs to n. So that means what? Here you have to replace everywhere k now. Instead of n, you have to replace k. So this is k. This is k. You have to replace everywhere k now. k. Okay. So now step 4. Step 4. We'll write here step 4. Step 4. We want to prove that. We want to prove pk plus 1 is true. So that is to prove that. That is to prove that uv k plus 1 is equal to k plus 1 c0 u k plus 1. Replace your k as k plus 1. Okay. So v plus k plus 1 c1 v k u k, this is u, plus k plus 1 c2 u k minus 1 v2. This sum should be the k plus 1. Okay. Plus dot plus k plus 1 cr u k plus 1 minus r vr dot k plus 1 c k plus 1 u v k plus 1. This we want to prove. Okay. So by step 3 we have this. Okay. Differentiate this, differentiating with respect to differentiating both sides with respect to x. Okay. We will differentiate both the sides with respect to x. So we are differentiating this with respect to x. So that means what? Just one derivative is added now. This is what? uv k plus 1. Okay. So one derivative, right? So what? If your derivative is k and you are taking the derivative, it will be the k plus 1 derivative. So you get here uv k plus 1. We will differentiate this. So now, so u and v are the functions of x. Okay. So what we will do then? Your kc0 is constant and we have to apply the product rule. Okay. So this is what then? u k plus 1. So first we will take the derivative of the first function. Your second function will be as it is. Then we will keep the first function as it is. We will take the derivative of the second function. Okay. So this is what? Derivative of uk is what? uk plus 1. Right. So plus uk as it is. Then this is v1. Then this is 1. See, this is 0 now here. So sum should be the k plus 1 everywhere. Okay. Plus k plus 1 ck plus 1. Okay. So ck1. Oh. So this is what? kc1. Okay. Now here we want k plus 1. This we want to prove. Okay. So that will do. Okay. So now this is what? Yeah, derivative of this will what then? uk. V as it is. Then uk minus 1 v2. uk minus 1 v2. Okay. Plus kc2. This is what? uk minus 1 v2 plus uk minus 2 v3. Okay. So we have to apply the product rule. Plus dot plus we have to write the net coefficient kcr. Then what? uk plus 1 minus r vr plus uk minus r vr plus 1. Okay. We have to take the derivative of this. Plus dot you have to apply the product rule everywhere. Okay. So u1 okay, vk plus vk plus 1. Okay. Now see here, this is not there. This first term will be as it is now, kc0. We will open the bracket now here, uk plus 1 v. This is a single term, nowhere. Now this ukv. Okay. So here what? Here it is wrong now. This is what? We are differentiating this k plus 1. Okay. Here what? uk v1. Then this is what? uk. Oh, this v1. Now we forgot this is what? v1. Okay. So now uk v1 is here. uk v1 is here. Okay. Clear here. your v1 is there. So your v1, you are taking differentiate this will be uk, your v1 will be as it is now here. Then uk minus 1 as it is, the derivative of v1 is v2. Okay. Now see here, uk v1 is here, this is here. Okay, so that means what here, plus kc0 plus kc1 uk v1. Okay, now see this and this are here, so that means what here, the coefficient is what, kc1 kc2 uk minus 1 v2. Now for this kcr, k plus 1 cr is here. So just previous one, this will be there. Okay, so that will what then, this will be what, the previous one is what, kcr minus 1 kcr u k plus 1 minus r vr plus dot dot dot, and we will collect only the last term, kck u vk plus 1 only. Okay, so this is what then, u v k plus 1. Okay, since kcr plus 1 is equal to k plus 1 cr plus 1 r plus 1, this is the formula, kcr plus 1. That means what, both the bottoms are same, and this is the difference between the bottom, both the tops are same, difference between the bottom is 1. Okay, then what, we have to increase the top by 1, and you have to take the maximum of this one, you have to take the maximum. So maximum of this one is what, r plus 1, maximum is r plus 1. Okay, and this is, you know that this is what, kc0 is same as kck, this is same as k plus 1 c0, this is same as k plus 1 c, k plus 1, this is equal to 1. Okay, so we are familiar with this one. Okay, so this formula, just we are using this, and we'll use this. So here, so this is what, u v k plus 1. We want to prove this one now. Now see here, this is what, kc0. This also we don't need, we'll erase this one also. Okay, now see, this is kc0. This kc0 you want k plus 1 c0. So we'll write this is what, k plus 1 c0 uk plus 1 v. uk plus 1 v there. Now this is what, see, the bottom is top is same, and difference between bottom is 1. So you have to increase bottom by 1, and you have to take the maximum of this one. So maximum of 0 and 1 is 1. So this is what, uk v1 plus, again this is what here, the top is same and difference between bottom is 1. So you have to increase the top by 1, and you have to take the maximum of this one. So this is what, uk minus 1 v2 plus dot dot plus, what is this, again this is what, top is same and difference between bottom is 1. So this is what, k plus 1 cr, what is the maximum, this is r minus 1 and this is r, so maximum is r now. So uk plus 1 minus r vr plus dot 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 k plus 1 c, k plus 1 u v k plus 1, your last term. This we can write kck, see here you have written kck is equal to k plus 1 ck plus 1, because value is 1, so you can write in whatever you want in terms of this. Okay, so now see, these two are the same now. Okay, so therefore pk plus 1 is true, pk plus 1 is true. So this we want to prove. Okay, so therefore by the principle of mathematical induction Pn is true for all n belong to n. Okay, so now your proof of the theorem is over here. Okay, now we'll do the problems on it. Find nth derivative of x square e raised to x cos x. Okay, so here what? You know the nth derivative of this one. You know the nth derivative of this one, e raised to x cos x. Okay, and the derivative of x square is vanishes. Derivative of x square is vanishes. Okay, so solution. Let y is equal to x square e raised to x cos x. Okay, so what we will write? Yn is equal to, by Leibnitz theorem. By Leibnitz theorem. So what is that? So what we will put? This u. We are taking the derivative of un minus 1 and so on. So we'll keep this u now, and we'll see this is v. So because what this v, so derivative of you take v such that its derivative will be vanished. Okay. So now see, this is what nc0 e raised to x cos x nth derivative. Okay, x square will be as it is. X square will be as it is. The next one, nc1 e raised to x cos x n minus 1/3 derivative of e raised to x cos x, and then x square, the first derivative of x square is twice x. Okay, plus nc2 e raised to x cos x n minus 2 derivative x square, second derivative of x square. Now see, what is the third derivative of x square? Is 0. So no need to write the next term, because all are 0 now here. It is enough to write the first three terms here, because if you write the fourth term, first three term, fourth term is what? Derivative of x square is derivative. The third derivative of x square you have to take. The third derivative of x square is what? 0. So no need to write the next term now here. We only have to simplify these three terms. Okay. So nc0 is what? 1. nc0 is 1. Okay. So what is the derivative of this one? Nth derivative of this is. Okay. So nth derivative of this is, your a is 1 and your b is also 1. Okay. So a square plus b square is 2. So 2 to the power n by 2. Right. R raised to n by 2. E raised to x as it is. Okay. Cos of x plus n tan inverse of 1. Tan inverse of b by a. Your b is what? Angle of coefficient of x from the angle. So this is 1. This is 1. Just will write tan inverse 1. Okay. If you are able to write the value of tan inverse 1, then you can write here. Okay. And x square will be as it is now. X square will be as it is. Plus nc1 is n. nc1 is always n. Okay. nc1 is n. Okay. So now n minus 1 derivative. This is what then? 2 raised to n minus 1 upon 2. You have to replace here n as n minus 1 now. Just write this. E raised to x cos of x plus n minus 1 tan inverse 1. And derivative of x square is twice x. Derivative of x square is twice x. Plus nc2 is what? N minus 1 upon 1 into 2. Just you have to reduce this n, write the n, go on separating 1. Okay. So take the product is what? 2 here. Just product 2. nc3. If you want to find nc3, what? Just reduce n by 1 by 1. So this is what? N minus 1, n minus 2 now. Okay. So these three products are there because there is 3 here. And upon what? 1, 2, 3. If you want to find nc4, what you have to do? n minus 1, n minus 2, n minus 3 now. Okay. See, these are the 4 products. Upon 1, 2, 3, 4. Okay. In this way you can find binomial coefficients. Okay. So nc2, again this is what? nc2. Okay. E raised to. Okay. So that is what? 2 raised to n minus 2 upon 2 e raised to x cos of x plus n minus 2 tan inverse of 1. And derivative of second derivative of this, that is first derivative of twice x. First derivative of twice x is 2. Okay. So now this is over now. So we just simplify this. So this is what? 2 n raised n by 2 e raised to x cos of x plus n pi by 4. N pi by 4. Because tan inverse 1 is pi by 4 into x square. You may write x square here also. Okay. Into x square. Plus I can write this is what? N x n into, okay, twice n I can write here. This is what? Twice n, 2 raised to n minus 1 upon 2 into x e raised to x cos of x plus n minus 1 pi by 4. This I can write like this. Here also I can shift x square here. Okay, x square here or okay. Plus. Now this is 2. 2 get cancelled here. 2 get cancelled here. So this is what? n minus 1 2 raised to n minus 2 upon 2 e raised to x cos of x plus n minus 2 pi by 4. Okay, so this is the problem is over now here. Okay, so only I have to do the 3 steps. Okay, within 3 steps your problem will be over. Okay, so this is very nice theorem to differentiate the product function n times. So that you have to differentiate n times the product term. Okay, so we'll take one more problem on it. Okay, suppose we have y is equal to x square sin x. We'll take the simple problems. Okay, so now derivative of x square is vanishes. Derivative of x square is vanishes. Okay, third derivative of x square is 0. We'll take this as v and we'll take this as u now. Okay, so by Leibniz theorem, what is yn? Yn is equal to nc0. Nth derivative of sin x, your x square will be as it is. nc1 sin x, n minus 1th derivative of sin x, and the first derivative of x square. This is the first derivative of x square plus nc2 n minus 2th derivative of sin x and the second derivative of this. See that your third derivative of x square is 0. So further all the terms are 0. So we are not writing all the next term now here. Okay, just we are simplifying this. So this is nc0 is 1. So this is what derivative of this is what sin of sin of x plus n x plus n pi by 2. X plus n pi by 2. X square will be as it is. Plus nc1 is n. You have to write all the 3 values here. Okay. Now n minus 1 derivative. This is what? Sin of x plus n minus 1 pi by 2. N minus 1 pi by 2. Derivative of x square is twice x. Just we will write here twice x. Now after that we will simplify this. Okay. N minus 1 upon 1 into 2. 2 factorial. Actually 2 factorial, but we will write 1 into 2. Okay. So sin of x plus n minus 2 pi by 2 into 2 now. So second derivative of x square means first derivative of twice x. Okay. Now just we will simplify. We will write this is what? X square sin of x plus n pi by 2 plus twice nx sin of x plus n minus 1 pi by 2. Don't forget to complete this bracket. Okay. Plus now this 2 get cancelled here. 2 get cancelled. So this is what? n minus 1 sin of x plus n minus 2 pi by 2. Okay. Now the problem is over here. Okay. So we'll take the next problem. In this way you can differentiate the product function. Okay. So keep v such that the derivative of that v is vanishes. Okay, if y is equal to a cos log x plus b sin log x, prove that x square yn plus 2 plus twice n plus 1 x yn plus 1 plus n square plus 1 yn is equal to 0. This we have to prove. Okay. So this is what? N plus 2. That means we have to take the n plus 2 to derivative of y. So before that, to take the n plus 2, so what we will do? We will find the second derivative of y and then we will jump for the nth derivative of y. Okay. Solution. Given that given that y is equal to this, just write, don't write it through that. Okay, so this we will keep here, but we don't write that. Okay, so we have to prove this one. Okay, we are given this y is equal to this. Okay, so we'll find y1 now. We'll find y1. Okay, so derivative of cos is minus. Okay, so minus a sine of log x into x now, into 1 upon x, into 1 upon x, right? Because derivative of log x, cos of something is minus sine of something into derivative of something. So this is 1 upon x plus b cos of log x into 1 upon x. So 1 upon x is there. We shift 1 upon x to this side. y1, x y1. Okay. So then this is what? Minus a sine of log x plus b cos of log x. Okay. Again we will differentiate this with respect to x. Okay. So differentiating with respect to x, we get. So this is what? X y2. Here you have to apply the product rule. X as it is, derivative of y1 is y2. Now your y1 as it is, derivative of x is 1. So this is what? X y2 plus y1 is equal to, we will differentiate this now. So minus a cos of log x into 1 upon x. This is minus now. Minus b sine of log x into 1 upon x. Okay. Now we will shift this x to this side. So what we get? X square y2 plus x y1, and see, this is your y. This is your y now. If you take the minus sign common, so it will be minus y. So this you have to do. You have to take the derivative. So write in the second derivative. You must get in the second derivative y. In the second derivative, see, this is the second derivative. You must get y here anywhere. Okay. So try to do this, right? So that means what? You have to remove this whatever given in this in x, right? So function x you have to remove, replace that in y now. So this is the crucial part now. So what we will do now, this is what? X square y2 plus x y1 plus y is equal to, plus y is equal to 0. Again differentiate this what? Differentiating with this n times, okay? N times. Differentiating n times with respect to x, or no, we don't write that with respect to, just differentiating n times by Leibnitz theorem. Okay. Okay. So here you have to apply the Leibnitz theorem. You have to apply the Leibnitz theorem here. Here there is no product, directly this one. Okay. For this, we'll do for this one. This is what? X square y2. You can find the nth derivative of y2. This derivative of x square, third derivative of x square is 0. That means you have to keep this is b and this is your u now. So this is what then? nc 0. This is your y2. Nth derivative of y2. Your x square is as it is. nc 1. N minus 1 derivative of y2, first derivative of x square. Okay, you have to write the product rule for this one, plus nc2, n minus 2 derivative of y2 and second derivative of x square. Now this is over now, because derivative of x square is second derivative is constant, because this is degree 2. If degree n, nth derivative is constant, n plus 1 derivative 0. So after that, what, all the terms are 0. So I am not writing that. Okay. So plus. Again we are applying the Leibniz theorem for this product. So this is what? nc0. Nth derivative y1. Your x will be as it is. Plus nc1. So first derivative of x is constant. Second derivative of x is 0. So I am not writing the further term. Okay. So here we have made a mistake. So n minus 1 derivative of y1 and first derivative this one. Okay. Okay. So plus. Now there is no product rule. So you have to write this. Okay. Now we'll simplify this now. We don't need this now. Okay. So after simplification we must get that. Okay. So we'll see whether. Okay. Go on solving. Automatically we will get this one. Okay. So now here what? We'll keep the bracket in. We'll simplify bracket in bracket. Okay. nc0 is 1 now. So nth derivative of y2 is nothing but yn plus 2. This is what? Yn plus 2. X square will be as it is now. Plus nc1 is n. Okay. So this is what? Yn minus yn plus 1 now. This is what? You have to take the sum of this one. N minus 1 plus 2 is n plus 1. And this is what? Twice x. This is twice x. Plus nc2. is n minus 1 upon 1 into 2. So this is y now. This is y. This is y. Okay. And second derivative of x square is nothing but first derivative of twice x. So that is 2. This is 2. Okay. So this first one is over. Okay. For plus we'll write here now. We'll write here. Okay. So NC0 is 1. NC0 is 1. So this is what? Yn plus 1 into x now. Plus NC1 is n. NC1 is n. This is what? Yn. This is yn. First derivative of x is 1. So this is ny. Okay. So this is completed here. Plus yn is equal to 0. Okay. Now we will collect yn plus 2, yn plus 1, yn and so on. Okay. First we will collect the yn plus 2. So this is x square, yn plus 2 plus. Now we will collect the yn plus 1. See, yn plus 1 is here, yn plus 1 is here. So this is what? Twice nx plus x, yn plus 1. Okay. So there are two terms. We will collect. This is what? Twice nx plus x now here. Now next we will collect the yn now. So yn. So for yn, so see, there are 3 yn. This yn, this yn, this yn. Okay. So these two get cancelled. This is what n into n minus 1. Okay. Plus n plus 1. Yn is equal to 0. Okay. Now simplify this. This is what? X square. See, x square yn plus 1. Okay. So look at that. So now here what? X is common, is taken here now. So don't take x common in the first one. Okay. So this is what we have to take the x common. Here you have to write this. Don't write here now. Okay. Because what? There x, yn plus 1. So yn plus 1. Plus, if you simplify this is what? N square minus n. Here minus n get cancelled. So this is n square plus 1. N square plus 1. Yn is equal to 0. Okay. So now this is over here. Okay. We'll do more problems on it. So if y1 plus m 1 m is equal to twice x, prove that x square minus 1 yn plus 2 plus twice n plus 1 x yn plus 1 plus n square minus m square y is equal to 0. Okay. So I have to prove this one. Okay. So we'll prove this one. So prove. Okay. Given that this. Okay. So given that this. Okay. We have to prove this. We'll keep this here on the board so that. Okay. Solution. Given that this. Okay. So now what we'll do? We'll multiply. This is what? We'll multiply by y to the power. Here we are multiply by y to the power 1 by m. Okay. So what is then y to the power 2 upon m plus 1 minus 2x y to the power 1 upon m. Okay. I have shifted this twice x to here. Okay. To avoid one step now. Okay. So this is what? Y to the power 1 upon m square minus twice x y to the power 1 upon m plus 1 is equal to 0. Okay. So now this is quadratic equation in y to the power m. This is quadratic equation in y to the power m. So we'll write the formula for this one. We'll write the root of this one. Y to the power m is equal to minus b. Minus b means twice x plus or minus b square minus 4ac. Your b square is what? 4x square minus 4ac. So minus 4. Minus 4ac. Your a is 1, b is minus twice x, and c is 1. Okay. So you are applying that formula. B plus or minus. Okay. This is what? Minus b plus or minus b square minus 4ac upon twice a. So upon 2. Okay. So y to the power m is equal to. So see here, 2. If you take the 4 here, the 2 here, and 2 get cancelled. This is what? X plus or minus root of x square minus 1. Root of x square minus 1. Okay. 2 get cancelled. So now y is equal to what? X plus root of x square minus 1 raised to m. Okay. Take. Okay. We'll take one root only. Now this is your y. Okay. Now we'll find the derivative of this now. We'll find derivative of this. Okay. So we'll find n plus 1 the derivative of n plus 2 the derivative of this. We must get that. Okay. So we'll see whether we get that or not. Okay. So this is y1. M x plus root of x square minus 1 raised to m minus 1 now. Into derivative of this. So derivative of this is 1 plus 1 upon 2 root of x square minus 1 into twice x. Into twice x. Okay. So y1 is equal to. So if it is not possible to convert your y1 in terms of y, then convert y2 in terms of y now. Okay. So try to convert y1 in terms of y. Okay. So that we will see how to convert that one. So this is what m. We have to simplify this. Root of x square minus 1 raised to m minus 1. Okay. Now if you simplify this, what? This is 2 get cancelled. So this is what? X square minus 1 plus x upon root of x square minus 1. Now see, this is both are the same now here. Right? This is your a to the power m minus 1 and this is a now. Okay. This is what x plus, you can read, this is x plus y same as y square. How we can write then y1? So we can write y1 as m x plus root of x square minus 1 raised to m now, raised to m upon root of x square minus 1. Root of x square minus 1. Okay. So now this is y now. This is what then? My upon root of x square minus 1. Okay. We'll take the square on both sides so that this root will get cancelled. This is y1. So this is what? M square y square upon x square minus 1. See here what we have converted y1 in terms of y now. Right? So that means what? In y in y1 we have y now. Okay. Okay. So what? We will shift this x square minus 1 here now. This is what then? Y square m square y square. Okay. So we'll take the first derivative. We'll take the first derivative. We don't need this also. We'll take the first derivative. Okay. I will take the first derivative here now. Okay. Because I want the whole board now. Okay. So we'll take the first. Here you have to apply the product rule. So this is what then? X square minus 1 twice y1 y2. The derivative of y1 square is what? 2y1 into derivative of y1. Derivative of y1 is y2. Okay. Plus y1 as it is now. Okay. y1 square as it is. This is what then? Twice x. This is twice x. Okay. Now here what? M square will be as it is. Derivative of y square is 2y y1. You have to put the power, derivative of the power by 1 and you have to multiply the derivative of y. Okay. Now see here, 2y1 is here, 2y1 is here, 2y1 is here. Okay. In each term contain 2y1, we will remove that. So this is what then? X square minus 1 y2 plus x y1 plus x y1 is equal to m square. This 2y1 get cancelled. So m square y. Okay. So differentiating n times differentiating n times. Oh, we have removed. Okay, no problem for this. Okay, so we'll manage that. Okay, no problem. Okay, now n times you have to apply the product rule here and here. So this will what then? M square y then. Okay. Okay, so we'll apply the Leibnitz theorem now. NC0 n nth derivative of y2 x square minus 1 as it is plus nc1 n minus 2 n minus 1th derivative of y2 first derivative of x square minus 1 plus nc2 so n minus 1 n minus 2 the derivative of y2 and second derivative of, this is polynomial in x second degree, so second derivative is constant, third derivative is 0, so we are not writing the rest of the term. Okay, plus nc0 nth derivative of this x will be as it is plus nc1 y1 n minus 1 first derivative of this, first derivative of x is constant, so this will be okay. So now this is equal to what then? M square yn. Okay, so we'll shift that m square y in the next step to this side. Okay, so we'll simplify this now. nc0 is 1 now. This is what? Yn plus 2 x square minus 1 as it is now. nc1 is n. Okay, n minus 1 derivative, you have to take the sum of this one. So this is yn plus 1. Okay, so you have to take the first derivative. So this is twice x plus nc2 n minus 1 upon 1 into 2. So you have to take the addition of the suffixes. So that is 2 n plus minus 2. So you have to add this. This will be the nth. Okay, and second derivative of this. Second derivative is nothing but the first derivative of this one. First derivative of this one. So that is 2 now. This is 2 plus. Okay, so we write here. Okay, we'll simplify this. No problem for this. This is what then? Yn plus 1 x. Yn plus 1 x. Plus nc1 is n. nc1 is n. So this is what then? Yn. Yn. And derivative of x is 1. Okay. So this is first. Minus m square yn is equal to 0. Okay. So now here. Okay. We'll rearrange this. We'll connect the yn plus 2, yn plus 1, yn. Okay. We'll connect the yn plus 2 first. This is what? X square minus 1, yn plus 2. Plus. Now we'll connect the yn plus 1. So yn plus 1 is here and yn plus 1 is here. So what are the coefficients of this? Is what? Twice n x. Okay. And there is what? X now. There is x. Yn plus 1. Now we'll collect yn now. So yn is here and yn is here. Okay. So we'll collect that. So your 2 get cancelled. This is n minus 1. Okay. Now plus n now. Plus n minus m square yn. This is equal to 0. Okay. Now this is what then? X square minus 1. Yn plus 2. Plus we'll take x common. So twice n plus 1. X. Yn plus 1. Plus n square minus n get cancelled. So this is n square minus m square yn is equal to 0. So automatically we get your required answer C. So now see whether we are correct or not. Just we check. Okay. So what? X square minus 1 yn plus 2 twice n plus 1 x yn plus 1 plus n square minus n y. Okay. So we get a correct answer. Okay. So I hope that you understand this one. Okay. We'll solve more problem solving in the next session. Okay. So now we'll stop here. Thank you.